Hello everyone, welcome to Dev Days Europe 2019. I hope you're enjoying this conference. In this session we're gonna talk about F# language, about functional programming, but mostly how to describe the domain, the business, business model which you are trying to with which you are trying to help the customers, the clients, whatever you work for, to solve some problems. So let's get acquainted. My name is Mikhail once again. I love F#. That's basically everything you need to know about me. I could also add that I'm a software developer for more than 10 years with the focus on .Net mainly, and so web development. But let's better talk about you. Is there anyone who's familiar with F# already? Okay, just a few people. That's great. Any .NET developers? Nice, that's better. Okay, so let's just briefly go through what F# is. F# is a functional first language. By functional first, I mean that it's a multi-paradigm language, so you can write objective-oriented code, or you can write like imperative code. Doesn't have to be functional or declarative, but the main paradigm is functional, of course. F# is also has a great algebraic data system, which helps us to build those business models, domain modeling, with a very powerful concept of pattern matching. I will show you what that means later on. It's cross-platform thanks to .NET Core. Microsoft has done a huge work on porting everything to Linux and Mac OS. So now F# runs basically on every platform, even probably on Android. But with the evolution of .NET, it will be more and more, I guess. And one more benefit of F# is that it compiles to JavaScript thanks to Fable. It's a transpiler from F# to Babel syntax tree, and you can basically use F# on backend and frontend. I guess this one is one of the biggest benefits nowadays. So why I like being a .NET developer? Of course, even now people think that .NET equals C#. So I was working always in C# language, writing imperative code, object-oriented, using object-oriented patterns, and at some point I started thinking that something is going wrong. Something is not as it should be. When reading the code, I found myself trying to understand what, trying to find the logic behind all those keywords, behind all those suffixes, which were used to, or prefixes like I for interfaces, like suffixes, something like factory or I don't know, singleton. And I started thinking, why do we why do we need them? Don't we want to write code which will be more understandable, better even plain English, which will be handled by the machine and then produce an application? Many of such things, like I don't know, always controlling what some object will give you, some method will give you. For example, in this example, you can see an order service returning the list of orders. But what if there is an exception? What if there is a null? List can be null, right? I don't know. I should be always aware of such things. I should always keep them in mind. I should always put some guards, checking for nulls, checking for some other edge cases. And after all that, after all those guards, we finally come to the business logic, where actual logic of the real life is described. Also, all those keyword noises like public, static, read-only, void, and blah blah blah. Like even class and struct, yeah, of course we have to know what the difference is and why we should use that. But for many cases, we just need to know that this is some type of some entity in the real world, and it doesn't matter class it is or a struct. Most likely it will be just class. I also find myself, probably some of you should be familiar with this picture, trying to describe the real world in enterprise, object-oriented terms, with all those factories, implementations, interfaces, whatever. Too much from my point of view. This is even the most strange example. Of course, you wouldn't find that in the real code, but who knows? Sometimes we find really weird things, really weird. So, why would why would we need to use that? I have an example. With all these things, we actually speak some language which only we as developers understand. And I would rather use some ubiquitous language with domain experts, so we talk in the same terms, speaking the same language, and we probably would be able to share some piece of code to confirm, to clarify the needs with the business people. I had a strange situation. Here you can see a JSON file. I had to implement a simple, very simple application that was a collection of feedbacks, how the support ticket was resolved or not. So it was a simple form with a couple of maybe fields and a button, and we had to do it in several languages, so we had to translate it. We ended up with this JSON file. It was, of course, bigger than this one. So it has a key and the value. Basically, everything you understand. It's clear that you need to translate "thank you" to a different language. And I sent that file to non-developers, to non-technical people, and asked them to fill it in several languages, just to put the translations into the values. And I received a refusal. Like I was rejected because I was told that we are not developers. We're not going to write code. This is code. This is not for us. And for me it was weird, but that's even not code. It's just a key and value. What else would you provide me with? Like an Excel table with one column and the second column? The same thing basically. But for them it was scary. Even the simple JSON, absolutely familiar for all of us, that was really scary for non-technical people. We just speak different languages, not even in terms of programming language. We just speak different languages. For example, a non-technical person doesn't basically use the word float for a number with a floating point. For them, it's just a number. Yeah, there might be it could be decimal. That's more kind of closer to their world, but nobody thinks of float or, I don't know, even integer. GUID, that's something absolutely strange. Or even string. People would rather use text, like a line of text, not string. And then I found out that there is F# language, and that language is as expressive as just plain English. You can write really pseudocode in comments, then uncomment, tweak a bit, and it will compile, and then it works. If the code compiles in F#, then it most likely works. Most probably, yeah. So let's see how we can model the real world with just types, thanks to really great and powerful type system in F#. Some things might look a bit weird for people unfamiliar with it, but I will try to explain you just on examples, just on naming, and let's see. So this is a very simple representation of a payment. Let's look on the bottom, actually. That's the most important. Yeah, in F#, the order of code matters. So from, let's say, from the credit card info type, we cannot we cannot reference payment until we explicitly say that. So in the payment type, you can see a type. You can see the fields, right, with no keywords, with no special names from the programming language. It's just amount and some payment amount. And for a non-technical people, for a business people, there is some payment amount. That's it. And there is some currency, and that currency could be either euro or US dollar. Just for simplification, of course, there are much more currencies. And the method, the payment method is of payment method type. So payment method is a discriminated union, so-called discriminated union. It's a sum type. The sum means that all possible values of this type could be just three, just summing the amount of cases, cash, check, or card. And each of them can have some additional data. For cash, we don't need any additional data. For check, we need check number. And the check number is of type int. This is also a discriminated union, but just with a single case. So basically, this is the type name, and this is the case label, and we use this for instantiating the type of integer. But we don't need to think of in these terms while dealing with the business logic. In the business logic, we have the type payment. Yeah, we create the check number with an integer. That's fine. Or a card number with a string. That's also fine. We are familiar with that. But with all those wrappings, small wrappings, then we operate with real names. This is a check number. It's not an integer for a business people. Let's have a look at another example. Let's suppose we have a company selling gadgets like phones or tablets, and each gadget should have, obviously, some code, some maybe ID or some code, SKU, if you will. Then it has a gadget name, then it has some weight and a screen size. As you can see here, again, there is no keyword. There is nothing which would tell to a non-technical people that there is something from programming language. Weight should be in grams, and the screen size should be in inches. Yes, internally, inches will be of float, but with the units of measure system in F#, we can even specify explicitly that the grams should be of an integer exactly grams, and inches of float inches. So later on, operating with them, you won't be able to replace. You won't be able to pass an integer into another integer if one is a gram and another is kilogram, and this will be done on the compilation time. We reduce the amount of tests for that because we don't need tests, otherwise it just won't compile. Everything is done on the static, strongly typed checks. For phone code, I wanted to point your attention also to a phone code. Here, I don't provide the code for it, but we can set a validation here inside, so you won't be able to instantiate phone code with just arbitrary string. It will have to have t in the beginning and 4 characters later after t. And for tablet code, it must be an integer, but in some range. So I don't provide it here, but the validation will be super simple. And again, it will be some things will be done, of course, on the compilation time. Some things will be done on the runtime side, on the runtime at the runtime. But at the end, we operate with these names, and the business logic we write, we use these names, not integers or strings or whatever. Later on, while selling these gadgets, the company should have orders, right? And with type, while modeling your domain with types, not with some strings or some tests, I don't know. When you specify types, we should understand that an unvalidated order is not the same as validated order, as a placed order. These are two different things. In functional programming, we encourage to use pure functions and immutability. So basically, we never mutate the state, and we try to avoid impure functions. So what a pure function is, it takes one entity, like one instance, could take an instance and output another instance, not mutating the initial one. So as for orders, let's imagine an order, if it comes to our system, it doesn't have any ID yet. It could have an address, and that address could be somehow faked, or I don't know, so it could be some random address which is not in the address book, right? So that will be another unvalidated thing, unvalidated address. And while validating, for example, an address, we could find out that there is no such address in the address book. So we need to put some explicit explanation that there might be missing value. Coming back to nulls, in F# there is no these types. These are called record types, by the way, and they cannot be null or uninitiated. Like, they must be either have some value, or just there is you cannot work with them differently. So to specifying that there could be some missing value, we use option type, and we explicitly tell to the user of this service that the value might be missing at the end. This is the implementation, the simple implementation of the option type. It's either sum of something, like the simple generic, right? So it will be validated address, or none. I won't go too deep into functional programming, but option type allows you to compose, and it allows you to kind of select from it. We call it map, but which you cannot do with nulls, obviously. But here I'm trying to say that we explicitly write everything. I told in the beginning that I would like to see the intention behind the code. Know those keywords, the intention that the value of validated address might be missing, and I explicitly say it in the code, and that will be visible. I won't need any check for null or for missing value if there is no option. I mean option type. There is also a great concept about the result. It's also a discriminated union. You can see that discriminated unions are used a lot in this in the language itself, because this is basically the way to compose the types. Because this is the result type. It's always, if you instantiate it with OK or with error, it will be anyway the result type, and you pass it as a result type. So these OK and error, don't confuse them with some types maybe based on the result. No, this is the concrete value of type result, either success or failure. And in our implementation, we also specify explicitly that there can be either paid invoice or payment error as a result of some operation, like operation is pay invoice, obviously. This works also with list, so result type can return not just one value, it can be something else. List, again, if you look at all these examples, you can see that there is the minimum of keywords, the minimum, the almost the most possible minimum of keywords, but it's just the plain English, which tells us that there are, for example, card type not recognized. What could be more understandable? And you can see that even list will be just a small word after the type, which tells us this is the list, the collection of these validation errors. This is an example of pattern matching, which I wanted to also show you. Even this one looks so simple in terms of the language itself. So you can see that we need to match card with something. So if it matches empty card, then gives us an active card with just one item in it. And if it matches with already active card, we just add another item to the existing items. If it's a paid card, we don't do anything and we just return the same card. So even this all looks so natural in terms of the language. Please match card with empty card. What simpler could you write in your code? And again, the minimum amount of keywords, just maybe some type. Pointed attention to type. Basically, if you compile it and to intermediate language and then decompile it to C#, for example, it will be a class, not a struct. It will be a class. So it's a reference type basically. But here we don't care. I mean, well, we could care. We could set it as a struct, like the value type. It will be stored in the stack instead of the heap. But here, we most likely would use a class even in C#. So type just gives us the information. This is a type. We don't need to think of all those classes, structs, whatever. Also for building from all these blocks, in F# we would rather use functions, not classes. I would like to show it to you. Just let's remember C#. So usually we have an interface and the implementation of that interface. And that interface could be, I don't know, some repository from which we get something. With F# we don't do that. We do everything in functions. So very simple example. We have a function which validates the order, possibly returning OK. I'm just skipping the internal logic. The validation could be completely not random, but arbitrary. Price order, which will somehow price the order, correct prices to it, some acknowledgement, and some events. And then we just compose all these functions with this awesome pipe operator. And our business logic at the end actually looks this way. So we have an invalidated order, we validate it, we price it, we acknowledge the order, and then we create the events after this process. As you could see, by the way, there are no types here. We don't use types here to say that this is an invalidated order. That's thanks to type inference in F#. You could be familiar with it from the link queue from extension methods. When you say select something, you don't provide the types explicitly. It's just inferred from the context. The same is done in F# almost always. Like it will understand from the context which type to use. But if you want to be explicit, there is a simple way. So you say that validate order actually takes an unvalidated order and produces a result of validated order and validation error as success or failure. And then you say that this function, validate order, is of type validate order. And then you just write it. Basically, this will be your argument of unvalidated order. The same we do with other functions. Again, very simple, the minimum amount of keywords, the minimum amount of even special characters. You can see that, yeah, this arrow, like a lambda arrow, even lighter than the usual one, because it's not equal sign, but just a dash. But everything else is just equals, a column, nothing special, no brackets, no curly braces or parentheses, nothing. Actually, this how would our logic look like with unvalidated when we say here result instead of some validated order only. So we will need to somehow bind it to result and result map, but there are also common operators for that which simplify the code even more. We can write it in more imperative way. You can see that there is no pipe operator for the whole workflow. It's just a couple of them. And then we basically assign to some value. It's not a variable because everything is immutable. You cannot mutate this variable after that. Then, for example, if our create events takes two parameters, two arguments, priced order and acknowledgement option, it's you will need both of them. So pipe operator won't work that well. But there's also possible to write some binder and it will be still simple. This is readable, I guess. With this example, I wanted to show you the carrying. If you're not familiar with carrying and partial application of a function, it's what we get out of box in F#. So if our function validate order takes three arguments: check product, code exists function, and check address exists function, and unvalidated should be order, I guess. Yeah. Sorry about that. We can pass only two arguments to it, and it will return us a new function with just one argument, the last one. And this works for any amount of arguments. So you can pass just one and get a function which expects two arguments, or vice versa, or just pass nothing and yeah, somehow rename the function this way. And then we will be able to just use it, this new validate order. This is also called shadowing. So we shadow this function with this value and then use it in this context. And this already a function expecting just one unvalidated order argument. Wrapping up, I would like to give credits to Scott Vloshin, actually, who inspired me on this talk, and actually inspires a lot of people on function of F# itself. He wrote a book, Domain Modeling Made Functional. If you read a book from Eric Evans, Domain-Driven Design, you probably, well, if you haven't read that one, you don't need it. You just read this one, the Domain Modeling Made Functional. It's, if not better, but at least not worse, and explains everything very good. And also, he has Scott Lawson has a website, F Sharp for Fun and Profit, as a further read for you. Just try hacking something with F Sharp. There is an article where he explains why F Sharp is the best enterprise language nowadays. I will share these slides later on, so you will be able to click on the links. You don't need to remember it. Also, I would encourage you to have a look at SafeStack. SafeStack is a set of technologies for functional first programming in F Sharp, for full stack programming in F Sharp. So you will be able to write backend and front end code just with a simple, there is a template, there is a lot of information. Just also have a look and try to hack something. Basically, that's it. Thank you all. I hope you have some questions, so feel free.